So welcome to the next lecture of Math 120. The previous lecture we were discussing determinants. Yes, determinant of a matrix. We discussed what is a minor and cofactors corresponding to any entry of a matrix. For example, if we have a matrix A can be written, I told you, in this way, Aij, where ij's are basically indices. I is from 1, 2 to so on n, and also j is from 1, 2 to so on n. I represents this row of the matrix, j represents the column of the matrix. And what is the order of this matrix? N cross n. You can write over here as well. So if this is the matrix, it's basically the compact form of the general matrix, which we write usually A11, A12, so on, A1n, and so on, AN1, AN2, so on, ANN. Okay. In a short form, we can write it in this way. Minors, we define minors. Let's just repeat very quickly. What is a minor of a matrix? A minor is basically denoted by Mij, and Mij corresponding to an element Aij of the matrix A is defined by Mij is equal to it was the determinant of a matrix obtained from this original matrix by deleting ith row and jth column. Okay, ith row and jth column, and in general, you can say, for example, if we have, let me write a matrix, 3 by 3 matrix, for example, or 4 by 4 matrix. 1, 1, A12, A13, A14, A21, A22, A23, A24, A31, A32, A33, A34, and A41, A42, A43, and A44. Okay. Basically, general form have been written in books. You can see from there. I'm gonna write here a minor corresponding to some of the entry, for example, A to 3. Then, how do we write it? We delete the second row, and third column. Okay. Of this matrix. What is the second row? This is the second row. And this is the third column. You delete this thing, these two things, and write the remaining matrix. We get the minor A11, A12, A14, and then A31, A32, A34, and A41, A42, A44. This is the minor of that matrix. And this is minor M. 2, 3. This is how we find the minors. It's basically the determinant of the matrix. Okay, I told you what is a minor in the previous lecture. So in short, we can obtain any minor of the matrix corresponding to any entry by deleting the row of that element and column of that element, by deleting these two things. This is the minor. Now, what is a cofactor? Cofactor of corresponding to any element was basically cofactors. Cofactor are basically denoted by Cij, and it is nothing but -1 power I plus j times ijth minor. This is the cofactor. Cofactor corresponding to the element corresponding to the element Aij of the matrix, given matrix A. So this is basically the definition of cofactor. For example, in the same matrix, if we want to find C23, then it would be -1 raised power 2 plus 3 times M23, which we have calculated above. So it's 2 plus 3 times A11, A12, A14, A31, A32, and A34, and A41, A42, and A44. So this is basically the cofactor of the matrix A corresponding to that element A23. So I told you similarly, we can find all the cofactors of a given matrix by first finding the minors corresponding to each element. So we have to calculate the minors. For example, we can say that it's a matrix Cij. C matrix is the matrix which contains all the cofactors corresponding to each element. C11, C12, C13, C21, and so on and so on. The last one is C44. So this is basically a matrix of cofactors, is a matrix of cofactors. Now, in order to find, still we haven't discussed how to find the determinant using cofactor expansion. After finding the cofactors corresponding to any element, we can find its inverse.
Sir,
how do we? Ji beta, yes.
Sir, the last thing which I've written in the form of a matrix, C is equal to C11. Can you please explain this last thing? This remains unclear.
C11. Where did I write this one?
So yes, sir, the last thing.
This one, okay? Cofactors, matrix of cofactors. It contains all the cofactors which we have defined here. What is Cij? It is -1 raised power I plus j times the minor, ijth minor. So if you use this definition, you can calculate all the cofactors in this matrix. For example, how do you find C11? C11 is nothing but -1 power 1 plus 1, ij, this is ij. So this is your I and this is your j, okay? Now, because I and j, they have indices from 1, 2, 3, and 4. So by varying all the values of ij, how many cofactors you can find? 16 cofactors, C11, 1, 2, so on, yes.
So are you trying to say that in the last matrix of C, we are supposed to use this cofactor Cij to calculate C11 and all these 16 cofactors in order to make this matrix?
Yes.
Okay.
Okay. Now, what is M11? It is nothing but -1 raised power 1 plus 1, which is 2. And it becomes -1 raised power 2 is 1 times the M11. M11 is what? The original matrix was basically this one, A, which has 16 entries. C11 would be what? C11 would be -1 raised power 2 times you delete the first row and first column and write the remaining entries in the form of a determinant. So it is A22, A23, A24, A32, A33, A34, and then A42, A43, and A44. So this is your C11. Now, if you want to find C12, then it would be -1 raised power 1 plus 2, which is -1, because -1 power 3 is -1. So times, you delete the first row and second column and write the remaining entries in this determinant, and you get C12. So similarly, you have to compute all the cofactors corresponding to each element in that given matrix.
Sir,
And up, जी बेटा,
sir, for any cofactor of this matrix, we need to find the minor, and for the minor, we need the determinant for a 3x3 matrix. So how will we get the 3x3 matrix?
Yes, we'll do it with the help of an example. First, you just focus on these definitions. Then we'll do an example, and then I'll explain you further about these things. Now, C is the matrix which contains all the cofactors, all the 16 cofactors. Now, adjoint of A is what? Adjoint of the given matrix is what? It is the transpose of C matrix. Okay. C is what? C is the matrix of cofactors. Matrix of cofactors of A, means of elements of A. Once you have calculated the adjoint of A, then you can find inverse of that given matrix, which is 1 over determinant of A times adjoint of A. This is how you find the matrix, the inverse of a matrix using cofactors. Okay. आपने ये 2 by 2 formula पढ़ा हुआ है. What is that? 1 over determinant of if the matrix A is what? If A is A, B, C, D, then how do you find matrix? You find the determinant of this matrix, which is AD minus BC. And then what is the adjoint of A here? Adjoint of A is you just replace the position of these two elements, DA, and then you just change the sign of these two things. Okay? You forget about this formula. You forget about this formula and use that procedure for a 2 cross 2 matrix. You'll get exactly this thing. This is basically a special case of that procedure which we have discussed right now. Okay? If you find, if you have to find the matrix, inverse of a 2 cross 2 matrix, you follow that procedure, you'll get exactly this same formula here, which you have used here. Okay, it's basically a special case.
समझ नहीं आया, आप किस formula को refer कर रहे हैं?
This one, A inverse is what? 1 over AD minus BC times DA negative B negative C. Okay, this is the formula for a 2 cross 2 matrix. Okay. In fact, this is a special case, or this formula can be obtained by using that procedure which we have discussed by finding cofactors corresponding to each element, and then find the inverse by using that determinant of a matrix, and then cofactors adjoint of A by finding cofactors of that matrix. Well, we get the same formula. That procedure is general procedure, okay? And if we take a particular case of that thing, we can, we would definitely arrive at this formula for 2 cross 2 matrix. There's a question in the chat window. Let me see, haven't got my quiz 1 score, I made it. Mohammed Shahroz, you send me an email that you didn't get the quiz mark. I'll do the needful. Okay. Now, let's get back to the determinants. We'll do examples of these things after discussing the theory corresponding to these topics. Now, the Cofactor expansion method for finding determinants. Cofactor expansions for finding determinants. all these methods, remember that all these procedures, methods are only valid for the square matrices. Okay. So if you have the same matrix A, which we have written there on the other board, if we have a matrix A, which is a 4 cross 4 matrix, A11, A12, so on, not so on, A13, A14. Okay, पहले हम इसकी general definitions देखते हैं. Cofactor expansions can be calculated along any row or any column. Okay, cofactor expansions can be defined along any row or column of the given matrix, of the given square matrix, in fact. Okay. Now, if A is a general matrix, we are going to define the general definition, and then we will take that particular case of 4 cross 4 matrix. The general matrix can be written in this form as well, Aij n cross n. So this is a matrix where the order of a matrix is n cross n, Aij. It obviously means that I varies from 1 to n, and j also varies from 1 to so on n. Now, what is the first row corresponding to this matrix? First row. If we expand this matrix, we get A11, A12, so on, A1n. Okay, so this is the first row. We are going to define the cofactor expansion corresponding to first row. Okay, first thing. What would be the cofactor expansion along this first row? So determinant of A is equal to summation, sum. What is changing in this row? Anyone?
The column.
Which index is changing?
The column index.
Columns. So what do we say here? Column from 1 to n, A1j, because 1 remains constant, 1 is the row, j varies, times C1j. Okay, this is how we define the cofactor expansion along the first row. And this cofactor expansion will give us the determinant of that corresponding matrix. I hope you get it. If you open this summation, I hope you know this notation of summation. Anybody, if you don't know, you can ask me. This is what? This is the sum notation. If we expand it, what do we obtain? A1j, sum on j only. So first we take the j equal to 1, j1, c1, 1, plus, then we take j is equal to 2. So then we have 1, 2, c1, 2. Then we take A1, the value of j, 3, c1, 3, plus so on. We take all the values of j till n, whatever the value of n is, plus the last value is what? A1n, c1n. Okay, this will give you the determinant of A. If we find the cofactors C11, C12, C13, and so on, C1n, and we multiply these cofactors with the corresponding element in A, we get the determinant of A. This is how we define the cofactor expansions along first row. Similarly, we can define cofactor expansion along any row. For example, if you want to find the determinant along maybe third row, the third row would be A31, A32, so on, A3n. Now, what does change here? Anybody? Can anyone tell me? What will change in this expansion?
We will replace 1 with 3.
Yes. We just replace here 1 by 3. All other things will remain same. Now here in this expansion, we get here 3, 3, 3, and 3. Okay. A31, A32, A33, and so on. Last one is A3n. And also in the cofactors will also change. यहाँ पे भी C31, C32, C33, and so on, C3n. So this is a cofactor expansion is a cofactor expansion. Factor expansion corresponding to third row. Okay. So similarly, we can find cofactor expansion along any row. I hope you get it. If you have any confusion, if you have any question, you can ask me. Now, in order to find the determinant of the given matrix, whatever the matrix is.
Sir, I'm sorry for interrupting. लेकिन sir, अगर ये cofactor expansion है, जो पहले हम cofactor matrix निकाल रहे थे, उसके लिए उसका क्या नाम होगा, उस process का?
That is only for finding A inverse. Okay. You find all the cofactors, and then you find the adjoint of that cofactor matrix, and then you can find the A inverse. But we didn't discuss how to find the determinant of a matrix having bigger orders, 3 by 3, 4 by 4, and so on. So this is how we are going to find the determinants by using cofactors. जी.
Sir, ये J equal 1 same रहेगा वो third row के लिए भी?
J 1 से n तक, देखिए ना J कहां से कहां तक वेरी कर रहा है third row में. If you take this row, what is fixed and what is varying? 3 is fixed, means row is fixed because the first index corresponds to the row. 3 remains same. What is varying? 1, 2, so on n. So J is varying. So that's why J कहां से कहां तक vary कर रहा है? 1 से लेकर n तक. So J is from 1 to n, A3J, C3J, because 3 is fixed because it is corresponding to third row. Third row में रो इंडेक्स हमेशा क्या रहेगी? कांस्टेंट रहेगी. ठीक है.
सर आर यू सेइंग सर हमने तो कहा था कि I एक रो होती है और J कॉलम होता है, तो ये J कॉलम ही है या रो है?
J इज अ कॉलम बेटा. देखिए J इसमें J वेरी कर रहा है ना. J 1 है पहले, फिर 2 है, एंड सो ऑन n है.
राइट सर.
तो ये सारों की कोफैक्टर एक्सपेंशन we define it along a row, always along a complete row. In general, if I say here, कोई भी रो आपने डिफाइन करनी है, तो in general आपकी जो कोफैक्टर एक्सपेंशन होगी along any row, वो क्या होगी? That also gives you determinant of A, and it would be summation J from 1 to n Aij Cij, where I is from 1 to so on to n. अब इसमें देखिए I जो है वो फिक्स है, I पे कोई समेशन नहीं है. You can choose any value of I, either 1, 2, 3 or any value of I. Value of I will be fixed. What is varying? Only J. J is from 1 to n. So in general, the cofactor expansion along any row would be defined in this way. AI1, CI1, okay? Plus AI2, CI2, plus so on, plus AIN, CIN. Now, whatever the value of I you choose, you can put there. I from 1 to n. If you want to define a cofactor expansion along the first row, you just put I is equal to 1 everywhere. You get the cofactor expansion along the first row, or second, or third, or so on, nth. So this is the general case, general formula for any ith row cofactor expansion along the ith row. जी बोलें आप, any question?
तो यानी किसी भी रो का हम कोफैक्टर एक्सपेंशन ले लें तो पूरे मैट्रिक्स का डिटरमिनेंट आ जाएगा.
Yes.
ठीक है सर.
Sir, I had a question.
जी बेटा.
Sir, how exactly are we supposed to find the cofactor ij without knowing how to find the determinant?
Okay, wait for a couple of moments, couple of minutes. After doing this, we are going to do an example, and then I'll tell you how to find the determinant, how to find the cofactor expansions, how to find the minors. Okay, we'll do this with the help of example. Now, I hope you get this concept, this cofactor expansion along any row. This is how you can define them. Okay. Now the question is whether we can find the determinants by writing cofactor expansions along any column. Yes, we can define cofactor expansions along any column as well. Okay, and how do we define them? The second thing is what? In that case, if you want to define a cofactor expansion along any column, let's, for example, define in a similar way. We choose first the first column, and we write the cofactor expansion along the first column. Now, this is your column. Now, it has A21, A31, and so on. The last entry is AN1. So now this is your first column. You are going to define a cofactor expansion along the first column. Okay. Then how do we define it? You just multiply this element with its corresponding cofactor, this element with its corresponding cofactor, and so on. The last element you multiply last element with its corresponding cofactor and add up them. You get the cofactor expansion. So if I'm going to write it A11, C11 plus A21, C21 plus A31, C31 plus so on. The last element is what? AN1, CN1. Now, this is a cofactor expansion along the first column. What you do, if you want to write a cofactor expansion along any row or any column, you multiply the elements of that column or that row with their corresponding cofactors, you get that expansion. Okay. In general, how can we write this thing? Now, what index is fixed in this case now? Anyone, tell me. Which index is fixed now?
J, sir.
J is now fixed, okay? The second index is fixed now. Now, how do we define it? Now, some will vary on ith index. So I from 1 to n, A, I. Now the column is fixed. Column is what? 1. C, I, 1. So this is how we define the cofactor expansion along the first column. Is a cofactor expansion along first column.
M नहीं होगा?
Nah, it's a square matrix. इट्स अ स्केयर मैट्रिक्स। दोनों का ऑर्डर क्या है? n क्रॉस n है। दोनों की जो इंडेक्स है वो i 1 से n और j 1 से n है। सो n is a fixed because it's a square matrix. So now you can see here that this j is fixed, column is fixed. What is varying now here? I. If we open this expansion, we get this thing. Similarly, we can define a cofactor expansion along any column. For example, if you want to define along the third column, in the third column, which index will be changed here? You have to write here only 3. Okay.
So that point makes sense, but what's the purpose of like doing it for a single column when we are like supposed to find the determinant of the entire matrix?
Yes. So basically, you can prove it that in order to find a determinant of any matrix, you can find the determinant by writing cofactor expansion along any row or any column. Okay, you can choose any row, you can choose any column, then you write the cofactor expansion along that particular row or that particular column. You find the cofactors corresponding to that elements of that row or column, write expansion, cofactor expansion, you get the determinant of that matrix. Okay, let's do an example now.
Sir, does this mean कि अगर कोई दो matrices हैं जिनकी कोई एक भी row या एक भी column like similar है, exact same है, so they'd have the same determinant?
No, their cofactors will change. Don't do that. So they would have different cofactors. I hope you get it.
One more short question, like when we were doing it previously, we wrote that in order to like make that cofactor, that C matrix, we need to find the determinant of each cofactor, that C11, that C22. So we have to find a determinant prior to making that matrix, and we are finding a determinant after making that C matrix. So what's the difference like?
Okay, now let's discuss these confusions with the help of an example. Okay. Now, if you have a matrix of 4 cross 4 and you have to find its determinant, it's a bit technical of finding basically minus of that matrix. Minus this one, no. Yes, let's have an example. Now, let me start with the 3 by 3 matrix. Okay. Then we'll do an example of 4 cross 4 matrix as well. You have 2, 1, 1, 2, negative 1, 1, 4, 0, 5. Okay. And you need to find the determinant of this matrix. Okay. Find determinant of A. Okay. Using cofactor expansions. Okay. Now, what you do here, you find all the cofactors, okay, first, or whatever. You need to find the determinant of this matrix. It's on you. How do you define the cofactor expansion and corresponding to any row or any column? I would prefer though that row or column which contains more zeros. For example, if I have to find the determinant of this matrix, I would go along this column because its coefficients are simple and this column has a 0 entry as well. So it will simplify my calculations. Because one of the coefficient is 0, I don't need to compute this cofactor because it will ultimately go to 0 when I multiply that cofactor with the 0 entry. Now, I'm going to find the determinant of this matrix using a cofactor expansion along the second column. Okay, along the second column, the cofactor expansion will be what? A second column. Remember it. 1, 2, C1, 2 plus A 2, 2, C2, 2 plus A 3, 2 A32, C32. Because it's basically 3 cross 3 matrix. So this will be your cofactor expansion for 3 cross 3 matrix. Now, this will go 0 because A32 is 0. Now, I have to compute only this C12 and C22. So A12, I know it. It is what? It is 1. Now, C12 is what? It is -1 raised power 1 plus 2 times the minor times, चले पहले ये line लिख लेते हैं. Sorry. Times minor 1, 2. Okay. Plus A22 is -1. And C22 is what? -1 raised power 2 plus 2 times minor 2, 2. Now, I'm going to, this is what? Negative raised power 3 into 1. So it is -1 times minor 1, 2 is what? How do we write minors? We delete the first row and second column. First row and second column, we delete it and write the remaining entries. 2, 1, 4, 5. This plus, यहाँ पे -1 power 4 is +1 into -1. We get again -1 times minor 2, 2. Minor 2, 2 is what? We obtain by deleting second row and second column. Okay. Second row and second column.
2, 4, 1, 5.
2, 4, 1, 5. Now you simplify this thing. How do you simplify this thing? You know how to find the determinant of 2 by 2 matrix. It's 2 times 10 minus 4 times 1. Okay, it is 2 times 5 minus 4 times 1, -1, and then determinant of this thing is same. Yes,
it's same.
It's 2 times
minus
5 minus 4 times 1. Okay. So now you simplify it, and -1 times 6, -1 times 6. And you get
12.
minus 12. -12. So this is your determinant. So the determinant of this matrix is -12.
So it's not 0. It's not 0. So it means that there lies an inverse of A.
Yes. If it is not 0, then we can find the inverse of that matrix. Okay. Now calculate all the other cofactors. Okay. You have this C12. C12 is what? C12 is 6. This is your C12, which is 6. And this is your what? C32. Sorry, not C32. C32. C22 is what? It is -6 again.
6. Negative. Yes.
Negative है या positive है? क्योंकि ये देखें, this is your cofactor C22, which is positive 6. ठीक है? So this is your C12 and this is your C22, and this one is -6. So this one is -6. Carefully. Now you already have C12, C22. You can calculate C11, which is -1 raised power 1 plus 1, times C11 is what? A minor. You delete first row and first column. You write -1, 1, 0, 5. Okay, you get here +1. You get -5. Okay, this is your C11. Now you people calculate all the cofactors and tell me. You calculate C12, C13, C21, C12 हमने calculate कर लिया है, C22 calculate कर लिया है, C23 calculate करें, C31, C32, and C33. You calculate all these cofactors and tell me the values.
So for C12, it's -6.
Okay, let me write the cofactors matrix. The cofactor matrix is C11 is -5 and C12 is what?
So -6.
-6. C12, C13 is what?
4.
4. C12 is negative. What is C22 is plus 6.
Sir,
So
sir,
tell me C21.
Sir, C13 is 6.
C13 is 6. And C12, sorry, C21 and 23.
C13 4 नहीं आ रहा.
C13 तो 4 ही है ना. Sorry, C13 या 31 आप कह रहे हैं? There is a difference there is a difference in C13 and C31. C13 is corresponding to first row and third column, and C31 is.
So C13 is 4.
Okay, that is correct. Tell me C21.
मुझे confusion है सर. C13 6 नहीं होगा.
C13 नहीं यार, C31 बोलो क्या है?
सर मैं वैसे पूछ रहा हूँ कि C13 निकाला कैसे, मुझे समझ नहीं आया. उसका 6 नहीं होना चाहिए.
C13 नहीं है ये 6. C13 4 है. C31 is 6. Somebody told me. Somebody told me. जी मुगीस बोले.
सर मैं पूछ रहा हूँ कि C13 आया कैसे, लाइक 4 कैलकुलेट कैसे हुआ. मुझे इसमें जरा कंफ्यूजन हो रही है, बस ये पूछ रहा हूँ.
क्या मसला है यार? कोफैक्टर्स कैसे फाइंड करते हैं? C13 कैसे कैलकुलेट करेंगे? You know that formula. You didn't get that point. C13 is what? Negative 1 raised to power 1 plus 3 times you delete the first row and third column. You get 2, 1, 2, negative 1. Okay. So this is plus 1 and minus 2, negative 4. Okay. So C13 is negative 4, not 4.
So C21 is negative 5.
Is negative 5.
And so C31, so it's not 6, it's 2.
Okay, it's 2. Tell me the remaining values of these cofactors. C23 is what?
Minus 4.
C23 is minus 4. C32 is?
So 0.
C23 is 0, obviously, because its entry is 0 here. And next, C33
so minus
is?
4. Minus 4.
Minus 4.
ये सारी minus 4 हैं?
Yes, sir.
पहली वाली 4 ही है मेरे ख्याल से, क्योंकि वहां पे देखें जहाँ पे निकाला था ना आपने C13, तो वो जगह minus 4 into minus 1.
Sir, C13 4 है sir.
हाँ, 4
minus
हो जाएगा.
First row and first column. अच्छा, ये मैंने कर लिया.
Negative 1 into 4, which is 1, and
2 negative 1 and 4 0. So it is 4. Yes, obviously. ठीक है. C13 is 4, not negative 4. So this is the matrix of cofactors. Now, in order to find the inverse of the given matrix, what do? You have all the cofactors. Now A inverse is what? A inverse is 1 over determinant of A times adjoint of A. Now, what is adjoint of A? The transpose of this matrix is, we know that it is adjoint of A. It is what? C transpose. So 1 over determinant of A. What is determinant of A? Is negative 1, 2 times the transpose of this matrix, which is negative 5, negative 6, 4. We are going to transform these rows into columns. Okay. So first row becomes first column now.
So then why are we writing it? Then sir, why are we writing it adjoint of A? Shouldn't it be adjoint of C?
No, it's adjoint of A, which is the transpose of the cofactor matrix.
Okay, sir.
Okay.
Yes, sir.
So it is negative 5, 6, negative 4, 2, 0, negative 4. Now you multiply this 1 by minus 12 inside with all the entries, you get the inverse. Okay. So this is your A inverse. First, we need to find the determinant of A by using cofactor expansions. If that determinant is non-zero, then we find all the remaining cofactors and find the A inverse. This is how we proceed. I hope you get it. If you have any question, you can ask me. Now, let's have an example of 4 cross 4 matrix. Then we shall move forward. Now, this one. This example is given on the slide number 39. Now, your A matrix is 3, 7, -3, 13, 0, -7, 2, 17, 3, 7, 1, 16, and then -3, -7, 3, -8. This is the matrix A. You have to find the inverse of this matrix, or find determinant of A first, and then A inverse. Okay, these two things we need to calculate here. How do we do it? First, we find the determinant of A, and determinant of A can be computed using a cofactor expansion along any row or any column. So which row or column would you prefer to write an expansion, cofactor expansion? Anyone?
First column.
Maybe first column.
First column or second row.
First column or second row. Okay. हमने पहले एक कॉलम लिख लिया है. Let's write now a row, second row. Second row में आप सबसे पहले cofactor expansion लिखें along the second row. Okay. You tell me. You also explain here that we find determinant of A using cofactor, or by computing cofactor by using cofactor expansion along second row. Okay, you tell me this thing so that I'm clear more about it. So determinant of A is what? It should be second row. Now remember, second row, A21, C21 plus A22, C22 plus A23, C23 plus A24, C24. Okay, this is the expansion. The first entry will be 0. This will be 0 because A21 is 0. Okay. Now, what we are going to calculate, C22, C23, C24. What we need here, C22, we need to compute this, C23 and C24. Okay, we need to compute this. Now, let me write C22. C22 is what? It is nothing but negative raised 1 raised power 2 plus 2 times M22. Now, what is your M22? This will be positive plus 1 times the determinant of the matrix by deleting second row and second column. So now you are going to delete the second row and second column. These two things you will delete and write the minor here. So it will give you 3, -3, 13, and 3, 1, 16, -3, 3, -8. Okay, this one. So this is your C22. Now, still you have a 3 cross 3 matrix. You cannot calculate this determinant straightforward. You cannot calculate it. You have to consider this again a matrix, and you have to write another cofactor expansion along any row or any column of this matrix in order to further compute the determinant of this matrix. Okay, you have to apply a cofactor expansion again in order to compute the determinant of this matrix. You apply subsequently cofactor expansions until you get the determinants of 2 cross 2 matrix. You got it? Now, individually, C22 is further basically we apply the same procedure in order to find the determinant of this matrix. Now, this is another question to you now. You have to find the determinant of this 3 cross 3 matrix. जो पहले हमने 3 cross 3 matrix का determinant find किया था, उसी तरह हम इसका determinant find करेंगे by using cofactor expansion along any row or any column. Okay. Then C23 calculate करेंगे, which is another question of finding determinant of 3 cross 3 matrix. Similarly, C24 calculate करेंगे, उसमें भी हम cofactor expansion use करेंगे in order to find the determinant of 3 cross 3 matrix. So you define cofactor expansions until you get determinants of 2 cross 2 matrices in the cofactor expansions. It's basically a very long and you can say that a tedious process of finding determinant of matrices. I hope you get it. If you have any question, you can ask me. Now, further, you are going to, in order to find C22, what you are going to do, you are going to define a cofactor expansion along first row or first column, any one. I'm going to define it along the first row, for example. So it is 3 times first row के corresponding है, ठीक है? So when you define the cofactor, this one minor along this one, what you do, you delete the first row and first column, and the minor would be what? 1, 16, 3, -8. -8. This plus -1. Sorry, यहाँ पे 3 times -1 raised power 1 plus 1 भी आएगा, ठीक है? यहाँ पे -3, यहाँ पे -3 is the coefficient, and cofactor expansion में आपके पास क्या आएगा? -1 की raise 1 power 1 plus 2 times, now you are going to delete first row and second column, so you get 3, 16, -3, -8. This plus 13 times -1 raised power 1 plus 3 times first row and third column, you get 3, 1, -3, 3. This one. Okay. Now you can simplify it because you have arrived at 2 by 2 determinants, which you can calculate immediately by multiplying these two and these two. Okay. Now you calculate C22. This completely, you get this the value of C22. After calculating this value, you go towards this thing, C23. Now you calculate C23, and then you calculate C24. Then you can calculate the determinant of A along this cofactor expansion. I hope you got all of this. If you have any confusion, you can ask me. I give you a few seconds to look at this. Think about it. If you have any confusion, you can ask me.
इस तरह तो हमें एंड में कोफैक्टर मैट्रिक्स निकालने के लिए हर एलिमेंट का कोफैक्टर निकालना पड़ेगा, और ये तो बहुत ही लंबा काम हो जाएगा. तो ये मतलब
पेपर में मैं आपको 10 by 10 मैट्रिक्स दूंगा और कहूंगा कि इसका डिटरमिनेंट फाइंड करें यूजिंग कोफैक्टर एक्सपेंशन. ठीक है?
काम दे रहा
ठीक है, तो आपका पूरा सेमेस्टर लग जाएगा उसको कोफैक्टर एक्सपेंशन फाइंड करने के लिए.
एंड में फिर भी नहीं होना.
एंड में फिर भी गलत होना है. मसला ही नहीं है, हो तो जाना है, पता नहीं अब ठीक हो गया नहीं. But it's a very tedious and lengthy process. Nobody uses this method currently in any kind of practical application. This is just a method. It has, I have to tell you because it's in the syllabus. The method which we use is a different method. We will use elementary row operations to find the determinant of any matrix. Okay. Elementary row operations के जरिए हमने पहले inverse भी find किया था, that is, I think, very fast and you can say convenient method to use in order to find the inverse of a matrix as well as the determinant of a matrix. I hope you get it. If you have any question in this thing, similarly, now you have to calculate the determinant, but this is your basically assignment. You have to complete these calculations. You have to find all the cofactors. You have to find the determinant of this matrix, and then you find all the 16 cofactors. You find the matrix of cofactors, you find the adjoint of that matrix, and then you have to calculate the A inverse. Okay, so you have to complete this example yourself.
So will we get such questions in the quiz?
Ji beta? Yes.
Will we get such questions in the quiz?
Is there a question? Maybe you get some question.
Is there a quiz in coming days?
Yes, there'll be a quiz in the next week on during the Wednesday's lecture.
Right, sir. Okay.
Now, some of the properties of these determinants we are going to discuss, and then पहले हम elementary row operations वाला method देख लेते हैं, and then we'll discuss the properties of the determinant in detail during the next lecture maybe. Let me now erase this thing. And then we are going to find the determinant of this matrix using elementary row operations. In determinants, elementary row operations, they are not exactly same as they were in the linear systems. Okay, remember this. Elementary row operations, I'm going to write here an important note. Elementary row operations for determinants. For determinants are slightly different from those of elementary row operations which we use in linear systems. What was the first row operation in linear systems? Anyone tell me?
Pivot entries को 1 बनाना होता था, जो non-zero entries हैं.
The first is that if we interchange any two rows, nothing will change in the linear system. Okay? Interchange any two rows. Row 1 को row 2 से आप interchange कर दें. There was nothing changed in the linear system. Okay? Because linear system में आप एक equation को तीसरी equation को उठा के चौथे नंबर पे रख दें, चौथे वाली को पहले पे रख दें, nothing will change. The solution of the linear system would remain same. But in determinants, it is slightly different. If you change any row, if you interchange any row with any other row, then if, for example, if a matrix B is obtained by interchanging any two rows, of a matrix A, then determinant of B is equal to negative of determinant of A. Means this is the first elementary row operation. What? If you interchange Ri with Rj, This implies that determinant of the new matrix is what? Negative times determinant of the old matrix. This is the first elementary row operation for determinants. अगर आप किसी भी डिटर्मिनेंट में कोई सी दो रो को इंटरचेंज करते हैं तो जो रिजल्टिंग डिटर्मिनेंट होगा या जो भी डिटर्मिनेंट होगा उसका साइन क्या होगा? चेंज होगा, नेगेटिव लग जाएगा बाहर. Let's do this thing. Let's apply this operation on this matrix. For example, now you need to find the determinant of this matrix. You first write the determinant. For example, अगर हमारे पास यहाँ पे 1 है, ठीक है, यहाँ पे 1 है. Okay, let me allow to put 1 here so that I may give you a reason. 1, 7, 1, 16, and -3, -7, 3, -8. Now, I'm going to, sorry, it's not a matrix, it's determinant. Now we are dealing with determinants, not the matrices. I'm going to reduce, in order to find the determinant using elementary row operations, I'm going to reduce this matrix into echelon form, okay? In order to reduce this determinant into echelon form by using elementary row operations, what we do, the first thing is you make 1 here, okay? You have to make 1 here in order to reduce this determinant into echelon form. So what operation do we need here? We interchange first and third row. Means R1 interchange with the R3. Okay. The resulting matrix will be what? The resulting matrix will be 1, 7, 1, 16, 0, -7, 2, 17, and then 3, 7, -3, 13, and -3, -7, 3, and -8. But according to the elementary operation for determinants, what we have to do, we have to put a negative sign here. Okay? Because we have interchange first and third row. जितनी interchanges आप करेंगे rows की, उतने बाहर negative signs आ जाएंगे. अगर मैं यहाँ पे दोबारा interchange करता हूँ कोई एक रो, तो पहले आपके पास -1 है यहाँ पे, फिर आपके पास एक और -1 आ जाएगा यहाँ पे, which is minus plus हो जाएगा. So this is how it works. Ji, now any question?
So this particular rule is only applicable when we are using these elementary row operations for finding the determinants.
Yes. These rules will be applicable only for the determinants. Okay?
Right.
The next rule, which I'm going to use, is what? I'm going to make this thing 0. Okay? The second operation, elementary row operation, which is allowed in determinants, is basically what? The second elementary row operation in determinant. That one is you can multiply any row and you can add it to any other row. The resulting row will be changed, Rj will be changed. This elementary row operation will remain same as we apply it in linear systems. Okay. These two elementary row operations, either they are in linear systems or in determinants, they are same. Nothing will be changed. Okay. Now we are going to apply this elementary row operations for determinants, and I'm going to make this one 0 and this one 0. Okay. What operations do we need here? -3R1 plus R3, and what is going to change? It is R3 is going to change. So after applying this operation, nothing will be changed. -1 remains here because you have to take this negative sign along with that determinant. Okay. Now, first row will remain same. 0, -7 to 17. Now, third row will change. Okay. You multiply this thing with the 3, -3, and add it here. So you get 0 here. -3, -21, and 7 is -14. -3, add -3, you get -6. -3, -48 plus 13. It is 35 negative. And the fourth row will remain, of course, same. -3, -7, 3, -8. Okay. Now, this is your determinant. Now, what you are going to do here, now you are going to make this entry 0. What operation do I need here? 3R1 plus R4. And which row is going to change? Row 4. Okay. Now, this operation will give me this matrix, this determinant, sorry, not matrix. 1, 7, 1, 16, 0, -2, -7, -2, 17, 0, -14, -6, -35. Now, row 4 will be, you multiply with 3 and add up here. So you get 0, 3 and add up here. You get 14, 3 and 6, 3. 48 minus 8 is 40. You get this thing. Okay. Now, what next? What we are going to do now? We are going to make this entry 1. Okay. Now, the third elementary row operation, which is allowed in the determinant, is this one, third one. If we multiply any row of a determinant, okay, or you can say that if a matrix B is obtained, if a matrix, not a matrix, if a determinant B is obtained by multiplying any row of A with, by a constant, then determinant of B is equal to, by a constant, say that constant is maybe C. Then determinant of B is what? It is 1 over C times determinant of A. What does it mean? It means that if you have to make 1 here and you are going to divide this row by 7, minus 7, then you have to what? Compensate this constant outside the determinant. So in order to make this one, -1, what minus 1 over 7 टाइम्स रो 2। ठीक है, आपने ये ऑपरेशन लगाया इसको 1 बनाने के लिए, तो जो रिजल्टिंग मैट्रिक्स होगा आपने -1/7 से डिवाइड किया, मींस 1/7 से मल्टीप्लाई किया, तो यू हैव टू कंपनसेट दिस कांस्टेंट आउटसाइड दैट डिटर्मिनेंट। यहाँ पे पहले -1 भी था, ठीक है, -1 भी था, और यहाँ पे आप -7 भी आ गया। नाउ यू कैन डू दिस 1 7 1 16 0 1 -2/7 and 17 -17/7. All the remaining things, remaining rows, they will remain same. 0 14 6 40. Okay, मीन्स आपने किसी भी रो को किसी कांस्टेंट से मल्टीप्लाई करना है तो बाहर आपने डिवाइड करना है, अगर अंदर आपने डिवाइड करना है किसी भी रो को तो बाहर आपने मल्टीप्लाई करना है सेम कांस्टेंट इन ऑर्डर टू कंपनसेट दैट कांस्टेंट। क्योंकि मैथमेटिक्स में आपने आपको पता होगा कि किसी कांस्टेंट से अगर मल्टीप्लाई करते हैं तो उसी कांस्टेंट से डिवाइड भी करते हैं इन ऑर्डर टू कंपनसेट दैट मल्टीप्लिकेशन। सो दिस इज व्हाट दैट रूल इज। So this is the third elementary row operation which we apply in order to find the determinants, in order to reduce the given determinant into echelon form. Okay.
Sir, I had a question.
जी जी बोले।
सर जब हम लीनियर सिस्टम्स में एलिमेंट्री रो ऑपरेशंस लगाते थे टू कम टू रिड्यूस्ड एचेलॉन फॉर्म, वी वर लुकिंग टू फाइंड सॉल्यूशंस फॉर दैट सिस्टम, राइट? तो जब हम डिटर्मिनेंट के लिए कर रहे हैं तो व्हाट पर्पस डज द रिड्यूस्ड एचेलॉन फॉर्म सर्व?
Okay, now what you are going to do here, I'll answer this question after 1 minute. What you are going to do, you are going to make these two entries 0. ठीक है, you are going to make these two entries 0, and then after this what you are going to do, you are going to make 1 here and then 0 here, and in the last you are going to make 1, sorry, this thing is 1 if it is possible. Now only these 3 elementary row operations are allowed in determinants. Okay, only these 3 elementary row operations are allowed in the determinants. After obtaining the echelon form, in fact, in echelon form, you don't need to make 1 here. I already told you. Okay, it is not necessary that you always make 1 here in the diagonal and 0 below. You can have some different constants here. We make 1 here in order to simplify, or for our convenience, in order to make these entries 0, we make 1 here. In echelon form, these diagonal entries may not be equal to 1. Now, after getting the echelon form, for example, after a couple of steps, after applying few elementary row operations for determinants, finally we obtain this, maybe we obtain 10 here or 15 here, and all other entries 0, if it is possible. Whatever here you have, it doesn't matter. Okay. Now you can see here that if we in order to find the determinant of this matrix, if we write a cofactor expansion along any row or any column, what do you get? If you try to write cofactor expansion along first row or first column, what do you get in order to find the determinant of this thing after reducing that given determinant into echelon form? Would it make your life easier to find the determinant?
Yes.
How?
We can only use the first column.
Yes, we can use only first column. First column, you write, you will left with this determinant, okay? This matrix, 1 this one, 0, 0, 10, 0, this one, and 15. Now further, you have to apply cofactor expansion again until you get a 2 by 2 determinant. Now, what you do here, you again apply a cofactor expansion along first column or first row. What do you get here? 1 times what? You get this matrix now. 10 times this, 0, 1, 5. This one. Now further, what is the determinant? 1 times what? 10 times 15. This one. This is the determinant. I hope you get it. If you have any confusion, you just ask me. Now, if you look up, if you go back, what is this product? It is basically the product of the diagonal entries. In that echelon form of that matrix. So once you have reduced any matrix into echelon form, the determinant of that matrix is what? It is nothing but the product of its diagonal entries. I hope you get it. If you have any confusion, you can ask me. Now, based on this observation, what we can say here, a very famous result, a theorem in fact, determinant of a triangular matrix. Triangular matrix is what? It is either upper triangular or lower triangular, or say scalar matrix or a diagonal matrix. Determinants of a triangular matrix is what? Is the product of its diagonal entries. So this is a theorem, which is very important theorem. Once you have, now what is, in fact, this is an upper triangular matrix. Okay, this is an upper triangular matrix. So what is its determinant? Its determinant is the product of its diagonal entries. I hope you get it. If you have any question, you can ask me. Now, I hope you got why we try to reduce the given determinant into echelon form. I hope you get it now.
सर
Yes.
एक सवाल है
जी बेटा.
सर हमने जो पिछले रो ऑपरेशंस किए थे, हमने जो कांस्टेंट वगैरह निकाले थे, उनका क्या हुआ? वो डिटरमिनेंट की कैलकुलेशन में कहाँ इस्तेमाल हुए?
यार वो हुए ना, 1 यहाँ पे -7 था, तो यहाँ पे आप 1 और -7 को साथ लिखेंगे. -1 और -7 को यहाँ पे साथ लिखेंगे इनफैक्ट. ठीक है, आपने बेसिकली इसका डिटरमिनेंट फाइंड किया ना. वो वाले कांस्टेंट्स जो हैं वो they will come along, they will not vanish. Okay, so this is basically the determinant of this thing only. Okay, the rest of the constants which we are bringing along that determinant, they would still stay there. Okay, so it is -1 and -7. Thank you.
Okay, sir. Thank you. Sir, how did you convert this 4 by 4 into 2 by 2?
How did I convert it? This is 4 by 4. I have just written the cofactor expansion along the first row. क्या आएगा? फर्स्ट रो का एक एलिमेंट आपके पास है ना, सॉरी फर्स्ट कॉलम, एक एलिमेंट आपका नॉन जीरो है, बाकी तीनों जीरो हैं. सो आई ओनली नीड टू राइट द फर्स्ट एंट्री अलोंग द फर्स्ट कोफैक्टर. बाकी तीनों जीरो हो जाएंगे, होंगे या नहीं? You got my point?
Sir, are you using that minor thing that you're removing the first row and the first column?
Yes. It's basically what? It is A11, C11 plus all others will be 0 along the first column. क्योंकि ये बाकी सारी entries 0 हैं. ठीक है? Now you obtain this sub matrix. This is minor. Okay. Now you write again the cofactor expansion along the first column here. What will be? What it will be? 1 times 1 times what? This sub matrix minor, which is 10 static 0 15. Now we obtain this 2 by 2 matrix, 2 by 2 determinant.
सर लेकिन एडजॉइंट निकालने के लिए हमें फिर भी कोफैक्टर्स चाहिए होंगे.
एडजॉइंट कौन निकालेगा यार? दफा करो उसको. कौन निकालेगा? If you don't need that was a very lengthy and hectic procedure. We don't. You will never ever use that method in any practical application. ठीक है? जी. Any question?
Sir, but can we assume कि ये टेस्ट भी नहीं होगा?
ये टेस्ट होगा क्योंकि ये सिलेबस में है. You should know the old things sometimes in order to understand the other things better.
Thank you, sir. We have a class at office.
Okay then, thank you very much. If you don't have any question, we are going to stop it here. Syllabus quiz का syllabus मैं email कर दूंगा. Don't worry about it.